So welcome back everyone. In this video, we are going to cover what are the different operations that we can perform using the on the IPv4 addresses. So let us begin. Okay, so there are certain operations that we can perform on an address. So right now we are going to, these operations can be like whatever the operations that we can perform on any binary number. We can perform the certain set of operations on IPv4 addresses as well. So in this case, we are going to just study about the three operations that are there that we can perform on binary numbers. So these are not, or, and, not and, or I guess it's clear. So in a not operator, it's basically a unary operator, as we all know, like only one operand is required. But in the case of and or, these are binary operators. So the meaning of binary operators is that there should be two operands in order for them to be in order for us to use them. So now let us start with the not operator. So not operation, how do we apply a not operation on a 32-bit address? So in the case of not operation, it's pretty simple. Like we will have just single input, which is a 32-bit number or 32-bit address, which will be our IPv4 address, and we'll have a certain output, which will be again 32-bit address, and it will be again IPv4 address. Okay, so as we all know, like in the case of a binary number, we just simply reverse the digits. Like zero, if it's zero, it will become one, and if it's one, then it will become zero. So like this is a simple example. Like this is the original number, and this we have the complemented this number. So this is actually after if my this IP address is IPv1. This address, if I represent this address with number A, then this is actually A bar. So I hope that makes sense. But what will happen if we have this representation in the form of let's say dotted decimal? So let's suppose if I have certain number 142.2.3.4. So what will happen? How will I identify the not operation on this? So the idea is pretty simple. All you have to do is just take every byte, take every byte that you have in the dotted decimal representation, which is 142, 2, 3, and 4, and subtract 255. Subtract that particular digit from 255. So 255 minus 142 will give me the not of this particular first byte, and similarly second, third, and fourth. So 255 minus 4 is 251, 255 minus 3 is 252, and it is 253. Sorry, it will be 253, and this one will be 255 minus 142, 523, and 541, and 1. It's 113. So it's 113.253.252.251. Similarly, there's one more example that we can see over here. This is the original number or original IPv4 address that we have, and we just simply take the complement, and this is the complement. 255 minus 17 is 238, 255 minus 121 is 134, and so on. So so that is the case. Now moving on, now we have bitwise AND operation. In the case of AND operation, as I told you, there will be two operators. So there will be two operands that we can have. So this is input 1 and this is input 2. So we have two IPv4 addresses which are 32 bits, and we'll have a single output which will be again 32 bits, and we'll have to perform AND. So the simple AND is like really simple. You just take 0 and 1, and if the digit is if both of the numbers are reversed, then you take the smaller one. If the both of the numbers are same, then you can take any of them. So that's the funda of AND operation. Let me just write it down over here for you. So if both digits are same, then take any of them. And this will be else case. Else take minimum out of them. Minimum of both of them. Okay, so like in this case, 0 and 1, if both of the digits are different, then it's 0. So that's the case of AND operation, and the same logic will apply when we represent it using we'll represent it using dotted decimal form. So let's suppose if I have certain number which is 255.240.255 dot 3, and we have another number which is 0 dot 255.127.4. Okay, so what will happen? So it says that when you are going to perform AND operation use on the dotted decimal for, notation of an IPv4 address, then it says that if either of the two numbers that you have, if any of them is 25 is or 0, if either of the byte, so if here we are talking about, when we say over here that we talk about each digit, then here we are considering each byte. So if each byte is either 255 or 0, then you will just simply replace it with the smallest one, which is smallest out of these two. So let's suppose if this is the case, then either of them is 255 or 255 or 0. So in this case, second one is 255, then we'll simply take the minimum out of them, so it will be 240. The AND operation will say that it will be 240, and in this case it will be 0. Similarly, in this case, it will be 127 since it is 255, and we'll have to take the minimum one. But what will happen in this case? So it says only if this is 255 or 0. Then if this is the case, like this is neither 0 or not neither 0 nor 255, then we'll have to simply move back to our previous ideology, which is representing it in the form of binary. So if we represent it in the form of binary, then 3 is 1 1 and 4 is 1 4 is actually 100, and just append few zeros, like to make it 8 bits, 00000. Yep. And 0000 and 0. Yep. And simply perform the AND operation. This is 1000 and 0 and 0, so it will be 0. And just represent it in the decimal form and put it over there. So that's the case of our dotted decimal form. And here's one example that I would like to show you. So in this case, let's suppose if I have this first number and 17.121.14.35, if we take the first byte, then in the case of first byte, we have certain 17 and 25. So since the second number is 255, second byte is 255, then we have taken the minimum, which is 17. Let me rub it for you so that you can see it's 17. And this one is also fine. It's actually 121 since 255 and 255 is there. Similarly, in this case, it's 0. So 0 is like if it's 0 or 255, then it's again 0. But what will happen in this case? So if it's 14, if it's something else than 0 or 255, then we'll have to simply take the represent them in the form of binary number. So for right now, I have represented them in the form of binary number. I am going to simply write it over here. So it will be 1110 and append 00000, and it will be 1000 1000 and 1100 I am going to do AND operation, which is 0 0 0 1 0 is 0 1 1 is 1 1 1 is 1 and 0 0 0 0. And if you represent it in the form of binary, if you convert this binary number into the decimal form, then it will be 12. So that is what we have done over here, and it's 12. So that will be all in the binary AND operation itself. What will happen in the case of OR operation? Let me just like tell you. It's also very simple. In the case of OR operator, what we do is we simply take the maximum out of them. So in the AND, we are taking the minimum. We have to do the same thing. Like if both digits are same, then we can take any of them. But if both digits are different, then we have to take the maximum out of them. So let me just show it to you. So in this case, like if 0 or 1, then we have to take the maximum, which is 1. If it's 0 or 1, then we have to take the maximum. But if it's if both the digits are like same, then we can take any of them. So that's the first case, and that's the second case. So similarly, if we apply, it's simple to it's very easy to apply it on a 32-bit address in the binary notation. But what will happen if we have to represent it in the form of a dotted decimal representation? Then in the case of dotted decimal, it's again simple. Like if either of the two numbers if either of the two digits that we are ORing, in this case, this is OR operator that we are applying. So if either of the two digits is 255 or 0, then we have to take the maximum, which will be 255 in our case. So 255, and again it's 255, and in this case it will be 35, since it is 0, 0 and 35, maximum out of them is 35. But what will happen in this case, it's again simple. You just have to convert both of them into the binary, and then take the OR operator, and then after taking the OR operator, you will have certain number in the binary notation. You can convert that particular number from binary to decimal and put it over there. So that's the case of OR operator as well. So that will be all for this video, guys. Thank you so much for watching. In the next video, we'll be learning about the classical addressing. So yeah, see you in the next one.